Welcome back to Daily Maths Concepts. In this presentation, I'm looking at AdMath, CXC AdMath 2019. I'm at question 2. And so question 2 reads, and it reads, express f of x equal negative 2x squared minus 7x minus 6 in the form a open bracket x plus h all square plus k. All right, so basically this is what we'll call completing the square. And so we are gonna be expressing this idea f of x is equal to negative 2x squared minus 7x minus 6. And we want to write this in the form. We want to write this in the form a x plus h squared plus k. We want to write it in that format. All right, there are many ways we can do this. So I'm just going to take it from one angle. I'm just going to use a formula to get out h and k, and then we do some explanation. All right. In this format, we can quickly find a value for h by using this formula. H is equal to b over 2a, and k can be found by using 4ac minus b squared all over 4a. And this same thing here can be written as, you can write this as c minus b squared over 4a. All right, so it's up to you. I'm going to be using this one here. All right, but you can use that one as well. It's up to you. But let's go. So in this, we're going to list what is A, what is B, what is C. All right, so let me quickly highlight some things that we know from previous classes. All right, definitely we know A is the coefficient of the square of X. So that's going to be my A. That's going to be my B, and this is definitely going to be my C. All right, so here it is. Let's write them down quickly. We have A, which is equal to negative 2, B, which is equal to negative 7, and C, which is equal to negative 6. So let us do some quick substitution here. All right, let's do some substitution. All right, so H is equal to B over 2A, and definitely we're looking at B, which is negative 7 over 2A, which is 2 times negative 2. So basically, H is equal to negative 7 over negative 4. And finally, 2 negative divide, we are going to get 4. So A is equal to 4. All right, let's go. So H is equal to 4. H is equal to 7 over 4. All right, very good. All right, H is equal to 7 over 4. All right, what is K? All right, what is K? So I'm going to take off some space here so I could do my K here. I'm going to do my K right here. All right, what is K? All right, so K is equal to 4AC minus B squared all over 4A. And what am I looking at? I'm definitely looking at 4 times A, which is negative 2, times C, which is negative 6, minus B squared, and B is negative 7, but this is squared, and we have all over 4 times A is negative 2. So let us go for it, making sure that we're not making any form of mistake here. All right, so we're talking about let's put this on our calculator. Well, this looks like positive 48. 8, 6 is 48, so this is 48 minus 49 all over negative 8. So I'm actually getting negative 1 over negative 8, and this is 1/8. So then if this is K and this is H, then I could just plug them in up here. All right, easily I can plug them in here. So basically what we're suggesting is that to complete this square, all right, to complete the square, we're going to be having a outside here, and it is -2. So we'll write -2, open bracket. X is always there. All right. And then we have the K value here, which is +7/4. There is a square here, and this K value here, which is +1/8. So there it is. It's in the format. It doesn't matter how you do it. The main thing is that you need to get it out. So if you can use a formula just to possibly easily get out your stuff, then you just work it and you go. All right. So there it is. We have completed the square for the 3 marks. All right. State the maximum value of f of x. What we ought to know, though, is this. So let me write back the idea. So the idea behind completing the square is this. This is the idea behind completing the square. All right. So I just want to quickly highlight this. All right. Let me quickly highlight these. All right, let me bring out my pen. Let's go. All right, what we're suggesting here is that we want to understand that these values that we find are extremely important. All right, because definitely this one, the K speaks to the maximum or the minimum. So a curve can either have a maximum or a minimum. So definitely in this context, the maximum value is any value that we would have gotten out there. So in this case, y is equal to, or you could say, this is the maximum value. All right, y is equal to 1/8. All right, so that the maximum value of f of x is equal to 1/8. All right, let's go. State the value of x for which f of x is maximum. We want to understand that at any maximum or minimum, there is only one x value, and that is the axis of symmetry. And then if we look back at this same thing we have here, this is what links to the axis of symmetry. So the axis of symmetry is the opposite of this. Matter of fact, the axis of symmetry is an x value, and it is the opposite of h. So in this context, state the value of x for which this is a maximum. It's going to be where x is equal to -7/4. So that's the point at which that's the x value at which f of x is a maximum. And all of those responses are from the completed square that we have. All right, it says use the answer in AI to determine all the values of x when f of x is equal to 0. The moment we speak about f of x is equal to 0, we're talking about solving. Understand? So if f of x is equal to 0, we're suggesting that, so -2x plus 7/4 all square plus 1/8, this is equal to 0. All right, so all we have to do now is just to do our maths. We're going to subtract. Let me try to get this. For some reason I could write this. Yeah, I'm going to write that. Let us subtract 8 from both sides. So we have -1/8. So we have -1/8. So we're subtracting that 1/8 from both sides. So let's rewrite what we have. We're going to have -2, open bracket, x plus 7/4 all square equal to -1/8. So that's what we have right now, because we subtracted. I'll bring this across and change the sign, whichever way we feel comfortable. What we're going to do now is to divide both sides by -2. So if you divide by -2, it means to multiply by -0.5, right? To divide by -2 means to multiply by -0.5. So in this context, this would have canceled. I'm left with, on this side, x plus 7/4 square, and this is equal to +116. So remember, -1/8 divide by -2/1 means -1/8 times -1/2. So that's what I was just saying here when I just did that, okay? So we're saying that this is that, all right? All right, let's continue working. We're solving. So at the same time, we could see here that in order to get rid of that, we're gonna have to take that and I take the square root of this. I'm going to be left with here. I'm going to be left with x plus 7 over 4, which is now equal to, because my square is now gone, plus or minus 1 over 4. Because the square root of 1 is 1, the square root of 16 is 4. So that's what we have there. All right, and then now we're going to subtract. We're going to be subtracting 7/4 from both sides. So we're subtracting 7/4. Let me just say this over. We're going to be subtracting 7/4 from both sides. But I'm going to put it here in front of this. All right. So, so right here, we're left with x only on this side, which is equal to negative 7 over 4 plus or minus 1 over 4. All right. Plus or minus 1 over 4. But definitely same denominator. So I could go equal negative 7 plus or minus 1 over 4, because I'm having that same denominator thing here. All right, so x is equal to that. So let us just go finally now we're saying, guess what? X is equal to negative 7 plus 1 over 4, or x is equal to negative 7 minus 1 over 4. So in this case, we're looking at negative 6 over 4. So x can be canceled down. Using 2, we get negative 3 over 2. All right. And this one will have negative 8 over 4. So x is equal to negative 2. All right. So those are my two values of x there. X is equal to negative 3 over 2, as well as x is equal to negative 2. And remember, negative 3 over 2 is the same thing as negative 1.5. All right, let's go further to see what else we're being asked to do. All right. So for this other question, it says sketch the function f of x and show your solution set. All right, when f of x is less than 0. All right, let's go for this first. If we're gonna sketch this. A sketch is a sketch. All right, so definitely we're not on a grid, so I'm just going to show some stuff that I have quickly. I'm going to show some stuff for my sketch quickly. All right, so here I would have my x, my y, and my x, or my x and my y. All right, so here I pull up my axis. This is x and this is y. Definitely remember, I'm going to put back the completed square here. So we had a negative 2x plus 7 over 4 square plus 1/8. So we have that to look at. All right. So while sketching this, we're saying that this part is the axis of symmetry. It deals with the axis of symmetry. So I'm getting the axis of symmetry as a negative, all right, negative 7 over 4. So it's somewhere over this side here. So this is negative 7 over 4. That's my axis of symmetry right there. And then my maximum is positive. So my maximum is positive 1/8. So I'm going to let that be another line, my positive 1/8. Use a blue line. So it's a positive 1/8. So it is somewhere here. I'm putting it somewhere there. Let me draw a better line. Right? So it is somewhere there. So that's my positive 1/8 right here. Now, so, and then the roots that we just got, we got negative 2, negative 1.5, right? -2, -1.5. So if you look, -2 would be somewhere here. -1.5 is somewhere here, or -3/2. All right, -3/2 right there. All right, so might not be properly balanced, but it's understandable. So this is where we're going to have our turning. So this is actually -7/4 meeting 1/8, right? All right, good. So that's my turning point there, and it's going to come here and here, and it's going to cross the y-axis somewhere. So let's see, where did it cross the y-axis, right? -6. All right. All right. So let's do our sketching here. So we're gonna go up through here, down here, come back down here, and that's our -6 down there. All right. So basically, this is a rough idea. Could have been drawn better, but that's just a rough sketch. All right. All right. So let me draw this back. All right, so that's a rough sketch of the curve. All right, so this is a sketch of the curve with the -6 there and everything. All right, so that's the sketch, what that this is referring to. And then it says sketch that and then show your solution set to where f of x is less than 0. So where it is less than 0, it's gonna be, I'm gonna shade it. All right. All right, so let me shade where it is less than 0. All right, so it's going to be less than 0. So it's going to be less than 0 under the x-axis. So we're talking about these areas here. You know, these areas, it's less than 0 there. It's less than 0 here. These areas, it's less than 0. So as much as I could go, to the right, it's going to be touching the curve somewhere down there. That's why we're saying, so as much as I could go to the left here, it's going to touch the curve somewhere down here. So it's less than 0 in those areas. So if we really look, these are the markers. So it's less than 0. We could say it's less than 0 where x, check this out, x is greater than, or yeah, it's just greater than -3/2, but it's going that way, so it's less than -2. So this is our solution. You know, this solution set though, we probably want to write it in a more official way to say, all right, we want to say, all right, so the solution of the set of x such that, you know, yeah, with values of x such that x is greater than -3/2 and the same x is less than -2. We could represent it like that. That's fine. All right. All right, let's go to our geometric. This is the last part says a geometric series can be written as y over x, written as y over x plus y squared over x squared plus y to the third over x to the fifth, and it goes on like that in that fashion. All right, so here's the idea that we want to look at now. It says here, prove that the sum to infinity is this. All right. In order to find the sum to infinity, we need to know what is the common ratio. We're going to need to know what is the common ratio. Since it's a geometric series has ratios. All right. So in this context, though, we can find the common, because this is my first term, that's my second term, and my third term. All right. So that's T1, that's T2, and that's T3. So what we're saying is, we can find the common ratio by dividing the term. So I can divide T2 by T1, and it's going to give me the same thing as T3 being divided by T2. Understand? So we can do that. So we could check it out now just to prove that it's a common ratio. All right. So let's go. So definitely y squared over x to the third. All right. If we divide this by y over x, I'm definitely sure it's going to give us the same value or the same expression as y to the third over x to the fifth being divided by y squared over x to the third. All right, so we should get the same thing if you do these. So let us go quickly. We're talking about y to the third over x to the third. When you divide, you can reciprocate, multiply, and we get that. Let's do some quick canceling here. Let me cancel. All right, so y cancel that, cancel that, leaving that. So I'm getting here y over x squared. I'm getting y over x squared here as a common ratio, y over x squared. So that's the common ratio, but I'm just proving that they will be the same. So I'm going to work this out. So y to the third over x to the fifth multiply by x to the third over y squared. You definitely could see the canceling going on. All of this cancel, leave 1, and all of this cancel, leave 2 down here. So I'm left with y at the top and x squared. So we have seen where, yes, these, hold on. Come on, my marker. We have seen where this is the common ratio, and we prove that we will get the same thing. So the common ratio, definitely, common ratio. So here are my common ratios. So my common ratio R is equal to y over x squared. That's the common ratio. All right. All right. And we know that this is the first term here, A. So we're set. Because so all we need to do now is to write the formula for the sum to infinity. All right, so the sum to infinity, the sum of a geometric series to infinity is equal to A over 1 minus R. And we're talking about when the modulus of R is less than 1. All right, so that's just a little condition for this formula right there. All right, so let's go for that. So we're going to put it in now. So we're talking about A. Let's look at what the A first term was. The first term was y over x. All right, so we're talking about this is equal to y over x over 1 minus R, and R is y over x squared. Now we can just take our time and do some math. Right under here, I'm still going to keep this as y over x, but underneath I'm going to work out this part right there. So in working out that part, let me just put this over 1. I'm going to have x squared here minus y all over x squared. All right. Now, if you really think what this is, right? This is really saying y over x divides by x squared minus y over x squared. But whenever we're dividing fractions, we can change division to multiplication and then reciprocate. So I'm going to apply that idea x squared minus y. Now here I'm seeing where yes, I see where some stuff can be canceled. Definitely I could cancel this x with one of that. So if I finalize what I have, I'm going to have xy at the top over x squared minus y. Well, definitely I'm almost there. So let us look back on what we ought to prove. We ought to prove that we have xy. All right, so we're going to have xy. We're supposed to have, this is what we want to prove that we, so I'm already here. Definitely we can simply pull out, because I'm seeing the answer now. I could pull out, all right, I could rewrite this. All right, let's take this and show what this really is right there. All right, let me put it in another color. Technically, this is x, y over 1 times 1 over x squared minus y. That's what this is, if I pull it apart. So technically, as you could see, this is xy out front, and it's left with x squared minus y, but this to the -1. And the reason why I'm going to put it to the -1, because 1 over anything means the inverse. So this is the inverse of it. Hence, we have proven that. We have just proven that. All right, thank you for watching. And if you like the video, please subscribe to Daily Maths Concepts and look out for more video. Question 3 for this will be coming out soon. Thank you for watching.